Hi guys, Miss O'Nay here. So today you will be working on a couple things, and I won't be there because I have a meeting. So I wanted to make you guys a quick video so you guys weren't too left out and so that you guys aren't behind for tomorrow. So December 2nd, you guys had the test yesterday. Hope it went well. Overall, I was really happy with your guys' scores, so awesome job. Today we are starting Unit 5, Molecular Geometry and Intermolecular Forces. Now that may sound intense, but it is a lot of connections between the other 4 units that we've already done this semester. That being said, you guys are going to start gearing up for the final. So yesterday when I was gone, we worked with all the other teachers on the final review packet, everything like that. And so just start to keep that in mind. Start to think back to the atomic models, the trends within the periodic table, atomic size, metal reactivity, naming and writing formulas. All of that's going to come right back. Unit 4 and Unit 5 will be really fresh. So start to think about that, and I know you guys will do great either way. My first period did ask me if I was going to have review sessions. I will have a bunch of those leading up to the final, so don't worry too much. That being said, you guys did just take the Unit 4 exam, and you guys will be getting that back today. So before we do anything else, I need you to do 2 things. Number 1, you need to pick up the Unit 5 packet, which should be at the desk. And number 2, you guys need to turn in your Unit 4 review packet. So please hit pause and go do that. Great, so you should have both packets turned in and picked up. The next thing that we are going to be talking about is your homework, capture question, and everything in Unit 5. So before we get started on everything, your homework over here, if you turn to page 2 and 3 in your new packet, please circle questions 1, 2, 3, 6, 7, 8, 9, 10. Okay? A lot of you will finish this in class, so I'm not going to be too worried. We will check those tomorrow when you come in, and I will be there. So that is your homework for tonight. You guys should have turned in your review packet, and then we are going to look at the capture question right after we talk about the test. So what I want you guys to do is to pick up your exams. You guys should pick up your written portion, which also has your multiple choice, as well as those little slips that I have cut out that have your multiple choice. So once you guys pick that up, I just want you guys to look through your multiple choice and take a minute to look at the written. And once you're done, give the test back to the sub. You do not need I need that back, okay? And if you have questions, we will talk about them tomorrow, but I do want you guys to be able to see your scores, look at the questions that you got wrong, compare and contrast with the people around you, okay? So go ahead, hit pause, and you guys can go ahead and do that. Awesome, so you guys probably have finished looking at the test. If you have questions, we will go over them tomorrow. Hopefully you were able to sort it out with the people around you. So we are going to start with our capture question. Our capture question is, how many valence electrons for an alkali metal family? What is the octet rule? And draw the LewisDot structure for chlorine, carbon, and neon. So this is thinking back a little bit. We are going back to valence electrons. You will need your periodic table today, as well as just a pencil in your packet, okay? So how many valence electrons for the alkali metal family? If you guys look on the periodic table, I'm going to take mine out for you. The periodic table has all of our different families, which we learned at the beginning of the semester. The alkali metal family is all the way over here. It's group 1, okay? How many valence electrons do they have? They only have 1 valence electron, okay? What is the octet rule? If you guys don't know this, this is just a review. Octet rule, octet means 8, and that is because all elements, or most elements I should say, want to reach a stable 8 electrons, okay? So there are a couple exceptions. I don't know if you guys remember some of them, but we will go over them today. The octet rule is just so that elements can reach a stable 8 electrons because they all want to be like the noble gases over here, okay? Then, last but not least, draw a LewisDot structure for chlorine, carbon, and neon. This is something that we did already, drawing the LewisDot structure for each type of element, okay? So please do that on a piece of paper. You guys can do it on the front of your packet, but draw your LewisDot structure for chlorine, carbon, and neon. Alright, so we are starting with target number 1, which says I can draw Lewis structures for chemical compounds and polyatomic ions. Right here we've got a quick review. Number 1, do you know your valence electrons? You should have that at the top of your periodic table. Number 2, what is a polyatomic ion? And number 3, does a negative charge add or lose electrons? Number 4, octet rule rocks. So that's what you are going to be. These 4 things are all going to be really important for drawing Lewis structures for chemical compounds and polyatomic ions. So valence electrons we've gone over. Alkali metal family has 1 valence, alkali earth has 2, halogens have 7, noble gases have 8, everything in between. Okay? Polyatomic ion. Poly means more than 1, ion means charged. Those polyatomic fancy ions are on the back of your periodic table. One good example could be sulfate or phosphate, all of those. Okay? Polyatomic ions also can have their own LewisDot structure. Number 3, does a negative charge add or lose electrons? A negative charge means that you will add an electron. So if I had the chlorine ion, which would be Cl minus 1, chlorine has a valence of 7, and then because it has a negative 1 charge, the overall valence would be a total of 8 electrons. If I had a positive charge, I would lose electrons, okay? Last but not least, octet rule rocks, and that is something that we have already talked about today. Drawing Lewis dot structures is really easy. We've already talked about how to draw Lewis dot structures for single atoms, for example, like this down here, and that's what your capture question was on. So, now we're going to be drawing Lewis dot structures for chemical compounds and polyatomic ions. So rule number 1 says all matter tends towards stability, meaning everything wants to be stable. Most atoms are stable when surrounded by 8 valence electrons, aka the octet rule, but there are a few exceptions. So we talked about this way back when, but hydrogen and helium are stable with just 2 electrons. Boron is stable with 6 electrons. Okay, so you guys don't need to write these down. I would maybe make a star next to it, but this is on the top of packet page 2. Okay, so continuing on, this is also on the top of packet page 2, but how to draw Lewis dot structures. If you follow along this little step-by-step breakdown, you will be fine. So number 1, determine the total number of valence electrons for the molecule. Draw a skeleton structure with a central atom bonded to all their atoms. Central atom is usually the one that occurs only once within the formula, okay? If there isn't a central atom, like if there's only 2 elements within the compound, then obviously you just need to make sure that they're connected. There won't be one central. Number 3, complete all octets and duets for all outer atoms. Number 4, place valence electrons, any extra ones on the central atom. Number 5, rearrange the electrons if necessary to make multiple bonds. So that rule number 1 is followed for every atom in the molecule. So we will rearrange electrons and make multiple bonds tomorrow. Today we're just worrying about polyatomic ions and making the compounds. Last but not least, 1 bond is equal to 2 electrons. This is really, really important. 1 bond is equal to 2 electrons. So, I know this is a lot of information and it may not make any sense, so we are going to try one together. And for this one, I'm going to be using a whiteboard and just showing you guys. This is not in your packet, so I just would like for you to follow along. Alright, so we are going to do some practice problems with compounds for Lewis dot structure, okay? So I'm going to be using my handy dandy whiteboard, and we are going to start with the compound of CH4. So I'm just going to turn you guys down a little bit so you can see this. So step 1 tells us for drawing a Lewis dot structure, we need to determine the total amount of valence electrons. So carbon has how many valence electrons? If you look on your periodic table, carbon has 4. Hydrogen has how many? It has 1. However, there are 4 hydrogen, right? So if I have 4 hydrogen, to multiply this by 4, which is equal to a total of 4. So total electrons together, my total amount of valence is 8 electrons. Okay? So now I need to draw a skeleton structure with my central atom bonded to the outer atoms. So my central atom is going to be the one that appears only once And it also tells me that good central atoms are carbon, nitrogen, phosphorus, sulfur, and sometimes oxygen. But we're going to use carbon. And to do a skeletal structure, the first thing I'm going to do is draw my carbon in the middle. And then I'm just going to branch off my outer atoms. Now, I know I have 4 hydrogens, so I need a hydrogen here, hydrogen here, hydrogen here. The only other place is up here. And they're not just floating in space, they're all bonded to each other. Okay? So now I have to actually check, do my total valence electrons equal the number of valence that I have here, and is everything stable? Hydrogen wants how many? Hydrogen only wants 2 electrons. Carbon wants 8. So let's see what we have. This hydrogen has a bond between the carbon and the hydrogen. One bond is equal to 2 electrons. So this hydrogen is happy. This hydrogen also has a bond, 2 electrons, happy. All good on all sides. Hydrogen is stable. Carbon needs 8. If each bond represents 2 electrons, I have 2, 4, 6, 8. Now my carbon's also happy. Now let's double check. Did I use all my electrons? Oops. Sorry guys. Did I use all my electrons? I had a total of 8 and I have 2, 4, 6, 8. So I am good to go. CH4, the compound for LewisDot would look exactly like this. If you want to draw the bonds as electrons, you absolutely can do that, but you need to just pick one way or the other. You can only draw the bonds as electrons if it is a single bond. So this would also be fine. You should just probably move your hydrogen in so I know that this is bonded to the carbon, okay? So I prefer doing the lines, but it's totally up to you, okay? So this is one really good example of a LewisDot structure. So I want to do another one with you. I'm actually going to do one that's on your homework. I'm going to do number 2 on your homework, okay? So let's all go to number 2. Now we know that number 2 is looking at the compound of NF3. Nitrogen has how many valence electrons? It has 5 valence. Fluorine has 7 valence, and there's 3 of them, so multiply that by 3. That gives me a total of 5 plus 21, which is equal to 26 total electrons, okay? So this is where I'm at. I've got 26 total electrons. Now I have to decide which one is my central atom. Nitrogen, right? There's only 1 nitrogen and 3 fluorine. So I'm going to draw nitrogen in the middle. And then I like to make it as symmetrical as possible. So I'm going to do a fluorine over here. I'm going to do a fluorine right here. I'm going to do a fluorine right here. Now, before counting electrons, the easiest thing to do is try to make sure everything is stable. So, is fluorine stable? They need 8 electrons, and they currently only have 2. So, I'm going to add these valence electrons. That's stable. That's stable. Now that's stable. But now left over is my nitrogen. I only have 2, 4, 6 electrons on my nitrogen. I still need another 2. So if I wanted to make it stable, I'd put another 2 up there. Now we need to make sure that this doesn't violate our number of total valence electrons, which is 26. So let's check. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So this is the LewisDot structure for our compound of NF3. So the key with this, you guys, figure out how many total valence, then put your central atom in the middle and just branch off your outer atoms and make them stable. It doesn't matter how many electrons you use. Check after you've made everything stable, okay? So we are going to do 2 more examples, and then you guys will start to practice on your own, okay? So these next 2 examples are not in your packet, but you can write them down on the front page. We are actually going to look at an ion, and we are going to look at chlorite, which is ClO2 minus. Okay, so we're going to throw in that charge at the end and see what happens. So chlorite. Cl has how many valence electrons? We've got 7. Oxygen has 6, and there's 2 of them. 6 times 2. So then I also have this negative. If I have a negative, do I add an electron or do I subtract an electron? Electrons are negative. I'm going to add one. So I'm going to say I also have one other electron. So let's add these up. 7 plus 12 plus 1. So this is like 8 plus 12. That's going to be a total of 20 valence electrons. What is my central atom? It's going to be the one that has only in there once, and that's going to be chlorine, okay? So I have 20 valence electrons total, and I know for my skeleton, chlorine's going to be in the middle, and like I said, I like to do everything so it's symmetrical, so I'm going to do oxygen on each side. This is what I have so far. Now, I'm not even going to worry about counting 20 valence electrons. I'm actually just going to make sure everything is stable. So chlorine needs how many more? It has 2 here, and it has 2 here, and it wants 8. So I need 4 more. 1, 2, 3, 4. Okay? Over here, I only have 2. I need 6 more. So I'm going to put all 6 around here. Remember, electrons go in pairs. And same thing on this side, all 6. Now that everything is stable, now I'm going to worry if it actually matches my 20 valence electrons. So let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So, worked out. I don't have to change anything. This is good. Okay? Now, the last finishing touch that we put on things, polyatomic ions, this charge is the overall charge of this compound. So by drawing it and not putting the overall charge, that's like saying this is neutral. So what we do is we put little brackets around and we carry that charge. It's a negative charge. Okay? Awesome. So we are going to now try one, a polyatomic ion that is positive. NH4 plus, okay? So NH4 plus, this is the polyatomic ion of ammonium, okay? So NH4 plus is going to be another example of a polyatomic ion for LewisDot structures. So first thing, find my valence electrons. Go ahead and do that on your own, okay? You guys can hit pause if you need to. Please try and draw it on your own, and then when you're ready, check back in, hit play, okay? So go ahead and hit pause. Okay, great. So hopefully you guys have figured this out already. I'm going to do this really fast. I've got NH4 plus. I've got to find my valence electrons. N is 5, H is 1 times 4, and then because it's a positive, I have to subtract an electron. So I have, instead of 9, I now have 8 valence electrons. When I do that, I know my middle central atom is nitrogen, and I'm just going to put my hydrogen all around it. I know that hydrogen only wants 2 electrons, and nitrogen wants 8. So your final answer should look like so. Okay, hydrogen only wants one bond to it, meaning 2 electrons. So this hydrogen's happy, this hydrogen, this hydrogen, this hydrogen, they're all good. Nitrogen, if you put in the middle, has 2, 4, 6, 8, so it's also happy. And just to double check, I only have 8 valence electrons, 2, 4, 6, 8. Can't forget your little charge, carry that over in brackets. So hopefully this is making sense, you guys. Go ahead and start on your homework, and we will check those in tomorrow. My last parting things is really just work through the steps on each one of these LewisDot structures, and you'll be fine. The biggest thing you should do is find your valence electrons, draw your skeleton, and make everything stable. Then go back and count, okay? So hopefully this was helpful, you guys, and you guys have the rest of the period to work on your homework. When you guys come back tomorrow, we will start by taking our give-a-thon photo. Everyone wear red, and then we will go over this and move on to part 2 of LewisDot structures, which is using double and triple bonds. So I will see you guys tomorrow. Thanks for being awesome, and have a great Wednesday, okay? Bye!